Hello guys, this is Mr. Elmbart here. I'm going over the Chapter 7 reading guide today. So, let's get through these following terms. The first one is momentum. Momentum is mass moving with some velocity, or you can think of it as mass times a velocity. Impulse is force over some time interval. Force in some time interval, or times by time interval. Elastic collisions are collisions that don't lose energy. And by lose energy, I mean lose energy of friction. They don't lose energy, their energy is conserved, so. To friction. Inelastic collisions do lose energy to friction. And specifically I'm talking about kinetic energy. Kinetic energy, KE for short. Completely inelastic collisions, those are the type of collisions that stick together. So they do lose kinetic energy and they stick together. Okay. So for number 6, internal forces are those that are inside a system. So inside, it's the name internal. And when I say system, usually I mean the problem being solved. So your momentum can't change from inside the system. Only from outside forces, like external forces, can the momentum change. So the equation for momentum is P equals mass times velocity, where P is momentum, M equals mass, V equals velocity. Our units for momentum is, of course, the units for mass, the kilogram, times the SI units for velocity, which is meters per second. And velocity is a scale vector because, momentum is a vector because velocity is a vector and because displacement is a vector. So, vector, the reason for that is because P equals mv, because v is a vector, and m, if you solve out what v is displacement, which is also a vector over time. And that little arrow on top I'm writing, that's a little vector symbol, just to say that's a vector. So vector, 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 they're all related. All right, quick little problem. For these, we always want to show our work. So P equals mv, we have a mass, 0.142 kilogram baseball, and it has the speed, 45.1 meters over second. We're going to assume it's the same as velocity, so we can use our equation. 0.142, and for all intents and purposes it is 45.1. I solve this out, I should get 6.4042 kilograms meters over second. Gotta make sure I'm using the right units for momentum. So changes in mass and velocity affect an object's momentum. Well, they will change it because they're part of the formula. So if we change the mass or we change the velocity, that will change the momentum. We get something, the change in momentum. This change in P. P final minus P initial. And when the object is doubled, so P equals mv normally, and then we do another equation, P equals m2 times v, well, this is going to be 2 over here. So we'll double the momentum. The change in momentum, like discussed up here, is P equals P final minus P initial, or mv final minus mv initial usually, because the mass doesn't usually change unless you're dealing with rockets, so we don't deal with rockets here. So factor out the m, v final minus v initial, or m times change in v. Oops, I ran out of room there. M times change in v. So the total momentum is where you add up the momentums. So however many momentums you have, you add them all up. So say I have 3, that means I add them up, get my answer. 4, add them up. 2, add them up. However many you have, just add them all up, and that's how you get your total. So when we relate the kinetic energy equation to this momentum equation, momentum is m times v. Kinetic energy from chapter 6 is 1/2 mv squared. So they're somewhat similar. They both have mass and velocity. And for number 15, since they both have mass and velocity, if the total momentum is 0, and momentum has mass and velocity, one of them has to be 0. Either the mass is 0 or the velocity is 0. Well, if one of them is 0, then kinetic energy also has to be 0 because it has the same quantities. So kinetic energy will be 0. Yes. Equation for impulse. Impulse equals change in momentum, which equals f times change in some time interval. So change in P equals change in momentum which equals impulse. It's a short way to say that. F equals force. We've talked about that before. And change in T is equal to a time interval. So the units for impulse, it's just a momentum, so we'll have the same unit for momentum. It's a change in momentum. We determine the direction from the impulse based on whichever change momentum value is bigger. So if the initial one's bigger, whichever is larger in the answer will give you what the direction is. So the momentum, velocities, the velocity will determine the direction. Velocity. Alright, quick problem. I get an impulse of this, that's I, and I have a force that I exert. They want to know the magnitude of the force if I have this time interval. The magnitude is always just the value. So magnitude, value, magnitude, value. Just nail that in your head. I have the force, though, that I need to find. So force question mark, that's what I want. Well, I know I equals F times change in T. So I just do 23 equals F times 25. Now I divide 25 to both sides. And I get F equals 23 over 25. And that should be newtons because it's a force. If you want to simplify that, I think it's 0.92 newtons. Okay. So momentum impulse theory. That is just I equals change in P equals F times change in T. Impulse and momentum are related because I equals change in P. Well, if we increase the time and F equals change in P over change in T, if we increase the time, usually the force will decrease if momentum stays the same. Right? So, in this case, in the purpose of a bike helmet, you're falling. If you're falling to the ground, you hit your head, you have the same momentum for both times, but the more your head has a cushion, like the more time your head is on the ground, the less force it has applied. You could also relate this to catching a ball. If you caught a ball like just like this, if you held your hand out, caught it, didn't move your hand back at all, it'd be kind of hard to catch. But if you moved your hand back a little bit with the ball, it'd be a little easier to catch. So that is how it relates to the force. You have less of a force if you you have a greater time to catch the object. So total momentum in the universe is always conserved. Because conservation momentum, P initial equals P final. That's the case for elastic and inelastic collisions. So external forces affect the system momentum. Does not. Internal does not. When a collision occurs, it's always just P initial equals P final. Elastic collisions and inelastic collisions. Well, elastic is when kinetic energy is conserved. It's unchanged. Inelastic is when it's not. Not conserved. Okay, so initial kinetic energy, this is the conservation of energy again. Energy initial equals energy final. And the final part, and technically is, I guess, kinetic energy initial equals kinetic energy final, is what happens to the kinetic energy lost? Well, it usually will turn into some kind of heat energy. It doesn't go away, it doesn't vanish, it just gets converted to something else. So it turns into friction. Catch-all for everything that relates to heat and stuff. Alright, so that's it. Have a good day.